My studies point to a bizarre and interesting possibility that we don't live in an objective reality and the entire universe might be just a super advanced virtual reality simulation. My name is Dr. Melvin Vopson. I was born in Bucharest, Romania. So in 2012 I joined the University of Portsmouth as a lecturer. Since 2014 I'm senior lecturer. And so I continue my research essentially in what I call the field of research. I would just to put a label on it, I would say condensed matter physics, solid state physics research. Landauer realized something very interesting. He realized that in thermodynamics we know there is a principle that any irreversible process has to be dissipative. In other words, if you have something that takes place irreversibly, you should expel some energy in this process, dissipate some energy. So if you could store information in vacuum, let's say, not supported by anything, you will still have an energy associated with this process, irreversible process. So the fact that information at erasure dissipates energy, it means that information is energy. It's like saying mathematics is physicalized. Mathematical states have an energy, if you want. It's a very, very abstract concept. If a bit of information is physical, so it has an energy associated to it which can be detected at erasure, my question was, where is that information going when the bit is at equilibrium and it stores information? That energy can't exist on its own, like it needs to be in some form, okay? One way of maintaining the energy is to condense it into matter. In other words, acquiring mass. And this is linked to Einstein's special relativity and the famous E/mc square relation, energy is mass. My mass energy information equivalence principle, formulated in 2019, states that information is not just a physical form of energy, but is also mass. It has mass. And it can interchange between these states depending on what the state information is in. If it's at equilibrium, storing information, that must have a small mass. The bit must have a small mass. If you erase it, that mass gets converted into energy dissipation. And then once you formulate this and you start looking at the physics from this angle and everything, then a number of very interesting possibilities emerge. Maybe we already are in some kind of digital virtual reality world. Maybe this already happened and is indistinguishable from the reality. One easy way of testing this would be to physically measure the mass of information. Okay, so you take a device of a given volume of information, you measure that mass, write it down, and then you erase everything and measure it again. If there is a mass change, in other words, a mass reduction, that would be the first proof that information has indeed mass. Maybe we can detect this information hidden in the particles by erasing it. Now, if you take an electron and a positron and let them collide, okay, they will annihilate and dissipate all their mass energy into gamma photons, okay? If they store information in themselves, about themselves, you should expect to see that information also conserved. It cannot disappear, it should be conserved. So all that mass information at erasure should dissipate somehow. I did the calculations and it should come out as infrared photons at room temperature at around 50 micron wavelength, okay? All you need to do is to do exactly what they are doing at the moment in terms of positron electron annihilation, but add a few more detectors there, specifically infrared detectors. The second signature is if you change the temperature of your environment, you should change the mass of the information bits in the particles. You should change, so the infrared information photons should scale with the temperature of the sample. So let's assume you detect them. The absolute confirmation is by changing the temperature of the sample and seeing the shift in the wavelength of these infrared information photons when detected. If you notice that as well, it's total confirmation of this, and it's a true eureka moment. So this is in a nutshell the experiment. Popular science articles that appeared, they talk about the simulation hypothesis and the world being, universe being a simulation, and this experiment may be proving that. But in fact, it doesn't prove entirely that. It underpins that concept through empirical evidence, but it doesn't mean necessarily that is totally the consensus is that that is what is happening, is one possibility. It's also wrong to assume that a negative experiment indicates that the theory is wrong. It means look more into this because we are onto something. But a positive experiment is a groundbreaking piece of research. It will force us to look back at the physics from this new angle and everything in it. It means that we missed an important component in everything, in all the physical processes and matter and everything, is the information component. It will revolutionize many things. It will bring changes in quantum mechanics, but the beauty is that it doesn't contradict anything. It's only complementary. It doesn't say special relativity is wrong or I don't know, thermodynamics is wrong. No, it doesn't contradict absolutely nothing. It's not exclusive, it's complementary to everything we do. It means we have additional tools to explain things that we overlooked in the past. You know, this information, DNA of matter, and this information component that is in everything, in the fabric of the universe, potentially in the space-time itself, it needs to be looked at. So it's a big game changer, it's a big thing, yes. If you are excited about uncovering one of the greatest mysteries in the universe, please support our experimental efforts by going to www.informationphysicsinstitute.org. Thank you very much.